Hello everyone. In the last video we had discussed about the different types of starting methods of the induction machine. Now in this video most important thing starting method, that is the star delta starting method, we'll discuss now. Now let's see, this method is different from the previous methods. Why? Because in the previous methods we have discussed about the DVL starter, and this is a direct online starter, and the resistance starting method and auto transform starting methods. That's all we are discussing about the star connected starter. Okay, but this method is only applicable for delta connected starter. That means in the running condition, the starter is connected in the delta configuration. Okay, but at the starting, in order to decrease the starting current, we are connecting it as a star connection. Okay, that's why star delta starting. Okay, initially star, and in the running condition we are connected as a again to the delta connection. Okay, so let's see how it is decreasing the starting current and what happens to the starting torque. All things we will discuss, and we will conclude the starting methods in this video. Now, so this is the normal without any starter, just I am connecting starting like delta. This is a DOL. Okay, so directly I am connecting voltage to the star delta connection induction machine. So let's see what is the starting current. Okay, starting line current, this is the starting supply or line current, supply current. Let's take, so first of all find out the what is the current here. So this is the phase current, this is the I phase of the motor. So I phase of the machine motor is equal to V phase by root 3. So let's take, this is a VL. So this voltage is also VL by, this is a ZS. Okay, VL by ZS. Okay, now this supply, starting supply current is equal to, what is the starting supply current? This one. So this current is equal to root 3 times of I phase. So that is equal to root 3 times of VL by ZS. Okay, now let's say calculate for this one also. This is the starting current with the star delta starting. Okay, initially we are connecting it as a star. Running connection again we are connecting like this, but I'm not concentrating in the running condition. I'm only concentrating on starting condition. Okay, now find out the starting phase current. That is the phase current is equal to line current of the supply, from the supply. So line current from the supply, that is equal to VL by root 3 by 1 ZS, that is equal to VL by root 3 into ZS. Okay, now let's denote this current as with the delta, sorry, this is star now. Okay, denote it as a star, and this is as a delta, or you can call it as a DOL starting. Now compare these two with this and with this. Okay, so I starting current with star divided by I starting current with delta, starting supply current. Okay, I already discussed previously, this is a supply current. Okay, that is equal to, see, if you divide, if I divide these two, this one and this one. Okay, sorry, this is not VL by root 3. So okay, over. So if I divide these two, what I will get, it is equal to, it's a star VL by ZS divided by root 3 by root 3 VL by ZS. So ZS cancel, will get 1 by root 3 into root 3, that is equal to 1 by 3. So I starting with star by I starting with delta. Delta means here DOL. Okay, so I starting with star is equal to 1 by 3 times of I starting with delta or DOL starter. DOL starting. Okay, that means the starting current with star is reduced. Okay, 1 by 3 times of with delta or DOL. And let us comment on torque also, what happens to the torque? Second point, that is a torque. T starting with star divided by T starting with delta, or you can call it as a DOL, direct online starting. Okay, as you know, starting torque is proportional to voltage square, V phase square. So what is the starting voltage in the star? That is equal to V phase by VL by root 3 whole square divided by phase voltage. You have to take phase voltage. Okay, so VL by root 3 whole square into with the delta. So here delta phase voltage is equal to line voltage, that is VL. So this one we will get T starting with star by T starting with delta, that is equal to 1 by 3. Okay, so this is the advantage with the star delta starting. Why? Because current also reduced by 1 by 3 times, starting torque is also reduced by 1 by 3 times. So that's why whenever we required, whenever we are using the delta connected starter, so we are go for star delta connection, and whenever we are using the star connected starter, we will go for auto transformer starting. Okay, so let us conclude here. Different methods we have discussed so far. Okay, so this is a conclusion of starting methods of induction machine. So we are having the two types of starting methods. One is the voltage, full voltage, and one is the reduced voltage. Okay, full voltage, that means we have the two types again. Full voltage applied to the star connected rotor and full voltage applied to the delta connected rotor. And in reduced voltage case, we have again three types. One is the resistor type, by using the resistor or reactant, and by using the auto transformer. These two methods are good for star connected rotor. Okay, so in resistor starting, supply current is reduced by x times and torque is reduced by x square times. Okay, and voltage is reduced by x times. Again in auto transformer, supply or line current is reduced by x square times, and motor current is as usual, that is x into I starting. Okay, this one motor current, and voltage is also reduced by x times, and starting torque is reduced by x square times. Okay, if we compare this one and this one, starting current or supply current is reduced by x square times here, but here only x times, and torques are same, both x square and x square. And for delta connected rotor, star delta connection is used. So in this, DOL is this one. In these two cases, DOL is this one. Okay, so I starting is equal to 1 by 3 times of ISC, and starting current is also reduced by 1 by 3 times, and the torque is also reduced by 1 by 3 times. Okay, and for general formula for solving the problems, general formula is I starting by I full load is equal to T starting by T full load is equal to I starting by I full load whole square into full load slip. Okay, remember one thing, this starting current is not the supply current, this is the starting motor current. Okay, and here also full load current is also starting motor current. Why? Because torque is defined based on the what motor taking, what current motor is taking, not on the supply. Okay, like in case of in case of auto transformer, so this one is, you have to substitute this one, not this one, that is in this relation, that is x into ISC, not x square into ISC. Okay, that's it for this. And some more doubts, where you will get the problems here, like based on the starting current, and mostly will get the problems on the starting current and starting torque and this relation. Okay, next one is, let's see, and one more thing is ISC. ISC means standstill current. Okay, standstill short circuit current at standstill, that is equal to V phase by ZS. V phase by ZS. For star connection, it will be equal to VL by root 3 into ZS. For delta connected rotor, this is for star connected rotor. For delta connected rotor, this will be equal to V phase equal to VL, that's why L by ZS for delta connected rotor. Okay, keep in mind these values. That's it. Okay, so by using these formulas we can able to solve any type of questions from the gate. In the next video we will solve some questions based on the starting methods of the induction machine, and I will post some questions in our electrical missions telegram group also. Okay, if you want notes, these notes, there I will post this notes PDF. Okay, please go and visit there. So thanks for watching these videos, and do subscribe to our channel, and like, and for any doubts you can post in our telegram groups. There so many people are there to solve your questions. Thank you.